Hey everybody, so this is the first lesson in the set theory unit where we're just going to go over some basics of what sets are and also talk about set notation and just go through some definitions that are going to be coming up all throughout the unit. So just to start with, what is a set? A set is a collection of distinguishable objects. So sets we didn't really talk about in grade 11 applied. Going back into grade 10 pre-cal and applied, we talked about set notation when it came to domain and range. And I think it also came up in like the functions part of the unit. But basically it can be numbers, it can be things. So like for example, if I said F is a set and it's a set of fruits, so it could be like apples and bananas and oranges. And I mean, the list could go on and on. Okay? So this is an example of a set. Or we could also talk about sets of numbers. So for example, if I say E is the even numbers, the set of even numbers. So 2, 4, 6, 8, 10, and so on and so on and so on. These are both examples of sets. But the point is each element, each thing in a set is distinguishable. It is different from all of the other things. So speaking of elements, elements are just things that are within a set. So in my set of even numbers, 2, 4, 6, 8, 10, and so on, those are each individual elements. The universal set is basically the set of everything that we are considering. Okay, so if we're talking about numbers, the universal set of numbers, well, if we're talking about integers, it could be all the integers. If we're talking about real numbers, it could be all the real numbers. If we're talking about fruits, it could be all of the fruits. Basically, the whole idea is, depending what it is that we're talking about, the universal set is the set of everything. A subset is when all of the things in one set are found in another set. The complement is all things that are in a universal set that do not belong to one of the sets. Empty set is when there's nothing in there. And disjoint is when we have two sets that have absolutely nothing in common. So for example, even versus odd numbers. Those are disjoint because there's no such thing as a number that is both even and odd. It's either one or the other. And there is notation involved. It is important whenever you write a set, make sure you use brackets, and more importantly, make sure you use curly brackets. Okay? Curly brackets. And that's how you're going to see it written all throughout here. So we'll take a look at that. So for example, if we said my universal set are the numbers 1, 2, and 3, U would be equal to curly brackets 1, 2, and 3. And every element in a set, we write a comma in between each of the different elements. Then we could make up another set called A. We could say that A is just the numbers 1 and 2. So A is equal to curly bracket 1 and 2. And because 1 and 2 are in the universal set 1, 2, 3, we could say that A is a subset of U. So all of A can be found in U. If it can't all be found in something, it's not a subset. It has to all be in both sets. The complement of A, so the complement is the things that are not in A, but are in U. So it's things that are not found in my subset A, but are found in my universal set U. So in this case, the only thing that's missing from A that is found in U is the number 3. So A with like a little tick mark or apostrophe, or you could write this squiggly line of A. Both of those things are called the complement. That's the notation for it. Is just equal to 3. And again, we write that in curly brackets because it is still a set. If you don't write the curly brackets, you will lose marks. So just kind of keep in mind. There's a whole bunch of different notation here for how to write the complement. The one that I have seen as well, which I don't see here, is A with a C in the top right corner. I'm pretty sure that also means the complement, but there are a whole bunch of different ways that you can define how you write the complement. And then if we include another set B that is a subset of U, but that contains the number 4, well, U doesn't have the number 4 in it, so B is just equal to the empty set because it doesn't exist in the universal set. It does not exist in this universe. So B is just empty, so you can just write curly brackets without anything inside, or you can write a 0 with a line through it. Both of these represent the empty set. And there is one more set of notation here. If we're talking about the number of elements in a set, so depending on what the letter is that we use the set, we write that as n with the letter of the set in the brackets. So for example, the number of things in my universal set U up here is 3, because there are 3 things in that set. The number of things in my set A, which was here, is 2, because there are 2 things in there. The number of things in my A complement is 1, because there's 1 thing in there. And the number of things in B, well again, B there's nothing there. So the number of things in B is 0. So we're going to take a look at some examples on the next page. All right, so in this first example, we have 5 different sets here, A, B, C, D, and E. A is the numbers from 1 to 9. C is the multiples of 3 that are between 1 and 9. B is my set of odd numbers. D is my numbers from 4 to 8. And E is my even numbers between 1 and 9. So part A says, determine any sets that are subsets of another set. So A is my biggest set. It includes all the numbers from 1 to 9. Each of my other sets here contains some of the numbers from 1 to 9. They all have, not all of them, but just some of the numbers. So in terms of subsets, we would say B is a subset of A. And the subset symbol kind of looks like a C. It's kind of like a little bit squished, I guess you could say. So B is a subset of A. C is a subset of A. D is a subset of A. And E is a subset of A. Again, because each of those sets contains some of the elements that are found in A. But now, do any of these sets, B, C, D, and E, contain any elements of each other? So I mean, like C is 3, 6, and 9, but B doesn't have a 6, D doesn't have a 3 or 9, E doesn't have a 3 or 9, so no. D has 4, 5, 6, 7, 8. Well, E is just the even numbers, so no 5 and 7. B is the odd numbers, so there's no 4, 6, 8. C doesn't have anything except for the 6. So if you just look through each of these individual sets, they don't have anything where one is completely contained within another. So in this case, these are the only subsets that there are. Part B says, are any of them complements of each other? And the answer is yes, because we were talking earlier about how even and odd are disjoint. Not only are they disjoint, but they are complements of each other because they make up all the numbers, all of the counting numbers that exist, basically. So in this case, B, the complement of B is E, and we can also say the complement of E is equal to B. And again, that's because both of these, they make up all of the numbers that are in A, but they have nothing in common with each other. But if we put them together, they make up A. And in this case, we can consider A to be our universal set because it has all of the elements really that we're looking for. Example number 2 says, George recorded possible sums that occur when you roll 2 4-sided dice, and he wrote them in this table here. So for example, if you roll 2 1s, you get a 2. If you roll 2 2s, you get a 4. A 3 and a 2 make a 5, and so on and so on. So we are going to be doing 3 different things in this example. Number 1, we're going to draw a Venn diagram. If you're not familiar with Venn diagrams, usually they are circles, and where the circles overlap with each other is where we put the things that they have in common. If there are things that are not in common but still belong in that circle, in that set, they're just going to go in the individual circle, so not in the overlap. So in this first part, we're going to draw a Venn diagram. Venn diagrams, we draw a rectangle, and then we draw the circles inside the rectangle. So the rectangle represents the universal set, and then the circles represent whatever the subsets of the universal set are. So in one circle, we're going to put the roles that make a sum less than 5, and in the other circle, we're going to put the sums that are greater than 5. So in this case, there's no overlap here because there's no way that something can be both less than 5 and greater than 5. So we're going to draw 2 individual circles here. The one on the left is going to be less than 5, and the one on the right is going to be greater than 5. So what are the roles that give me less than 5? Well, I've got 1 and 1. I've got 1 and 2, 2 and 1, 3 and 1, and 1 and 3. And I ran out of room here, but 2 and 2. Should have maybe drawn it just a little bit bigger. So make sure that you make your circles bigger. And then the roles that give me sums that are greater than 5, these are all these ones here. So the ones that give me 6, 4, 2, 3, 3, 2, 4, then 4, 3, and 3, 4, and then 4 and 4. And again, I'm sorry that that is so small, but hopefully you can see from the table the ones that are less than 5 and the ones that are greater than 5. In part B, it says how many things are in each set. So if I'm going to call this the ones that are less than 5, I'm going to call that L. So the number of things in set L are 6 because there are 6 possible roles. The number of things in G is also 6 because there are 6 possible roles that are greater than 5. Part C says determine a formula for the number of ways that a sum less than or greater than 5 can occur. Well, we know that the number of ways that are less than 5, and we know that the number of ways are greater than 5 is just 6 plus 6, which is 12. And we also know that there are 4 ways that the sum can be 5. That the sum can be 5. I'm not sure exactly what it's looking for in terms of the formula, so I might get back to that one. But we're going to take a look at the final example, example number 3, where we have, this time we're dealing with words instead of numbers. So we have C, which is my universal set. We have a set here S. We have a set H, which is completely contained within S. And we have a set called W. So the first part of this example says, what might each of these letters represent? Well, if you look at all of the stuff that is in here, I mean, these are all like different types of clothing. So we could say C, which is my universal set, is clothes. We could say that S, if you look at the elements within S, those are my summer clothes. W has things that we wear for winter, so W could be my winter clothes. And then H, which is contained within S, this could be just like my accessories, for example. All right, which ones are subsets? Well, because C is my universal set, each of my things contained within C are subsets of C. So, S is a subset of C, H is a subset of C, and W is a subset of C. Each of these sets is contained within the universal set C. But there is another one here. My H is fully contained within my S, so H is also a subset of S. Part C, list any disjoint sets. So these are sets that have nothing in common. There are no overlaps between them. In this case, S and W, they have no overlap, so they are disjoint sets. And then part D says, is the complement of S equal to W? The answer is no, because there are elements in my universal set C that are not in either S or W. So by that, I'm talking about the jeans and I'm talking about the raincoat. For something to be a subset, or sorry, for something to be a complement of the other, all of the elements have to either be in one set or the other set. But in this case, we do have elements that are in neither set, which means that they cannot be complements.